and welcome back to the EV Life podcast. I'm Crystal.
I'm Hannah Neal.
And today's episode is all about solid state batteries.
Yeah, so we talked to Linda Nazar of University of Waterloo. She's a Canada Research Chair and professor there in solid state energy materials. And so, yeah, she basically breaks down what a solid state battery is.
She gives us like a very technical, I guess, look at what exactly those batteries are and how they differ from the traditional lithium-ion batteries that most EVs have right now.
Yeah, it was really interesting because, solid state batteries have kind of been a conversation more and more in the news. And so she kind of lets us know how soon we might see them on the road. And
spoiler, it's a little different than what some of the OEMs have been saying.
Yeah. And so, it's interesting to know that this is something that's coming in the future and still being developed in the market. So,
so here, let's take a listen to what Linda had to say about solid state batteries. And if you have any thoughts on this episode or any of our episodes, make sure you connect with us in the EV Life group on the AMA mobile app. Enjoy today's episode. Hi, Linda. Thank you so much for joining me on the podcast today.
Hi, pleased to be here.
Can you share with our audience just a little bit about your background and the work that you do?
So I did my PhD at the University of Toronto.
Okay.
And I did that in inorganic materials chemistry. And then I went on to do a postdoctoral fellowship at the Exxon Corporate Research Labs in New Jersey, which was kind of it was a huge, almost a quasi-academic industrial setting. And then I came back to Canada, to Waterloo, to start off as an assistant professor. And now I'm a full professor in Canada Research Chair and university professor.
Nice. And then can you tell me a little bit about the work that you do in solid state energy materials?
Yeah, well, it's a pretty big topic. So solid state energy materials can cover everything from energy storage to conversion to a variety of different concepts. I work in energy storage, and the materials that we work with are really the electrodes and the electrolytes in the battery. So some of our work is actually not in solid state materials, it's actually in liquid electrolytes. But a good portion of it is in the solids that comprise the electrodes, and as I said, the solids that comprise the electrolytes.
Okay, and then just for our audience who may not know, can you just explain a little bit about what exactly a solid state battery is and how it differs from lithium-ion batteries, which is what we're used to seeing in electric vehicles?
Sure. So normal or traditional lithium-ion batteries have two electrodes, the positive and the negative. And between them is a separator, which is electrically insulating, but it allows ions to pass back and forth between the two electrodes. Sort of like sodium chloride has sodium ions. In this case, they're lithium ions. And they're contained in a liquid electrolyte, which is an organic solvent, which is usually they're called alkyl carbonates. And so the salt, just like it would be sodium chloride, but in this case it's a lithium salt, is dissolved in that organic. So that allows the electrons to pass through the external circuit, which is where they do the work for your laptop or cell phone. Mm-hmm. And the ions pass back and forth between the two electrodes to counterbalance the negative charge of the electrons. So that's how a normal battery works. And a solid state battery is simply one in which the electrolyte is a solid instead of being a liquid. And so that electrolyte has to be contained, for example, in the positive electrode and mixed with the positive electrode material, but it also has to be contained in that separator. It forms the separator between the two electrodes. So the simple answer is that the electrolyte that carries the ions is a solid, not a liquid.
Right. And, solid state batteries are kind of a hot button topic right now with electric vehicles because we know that they're supposed to, I guess, improve the experience for EV owners. So can you just maybe highlight some of the advantages of a solid state battery in terms of safety, charging range, whatever it may be?
They're really not on the mass market yet, so it's a little hard to estimate some of these things. But the main factor they have is safety. Now, there's two kinds of solid-state electrolytes, what we call ceramics, which are not like your teacup ceramics, but they're solids, inorganic solids. And the others are polymers. And solid-state batteries comprising polymers are actually on the market. For example, there's a company called Bolloré that actually markets these, and they're used in buses. But because the polymer is organic, they still have the potential for flammability, whereas the inorganic or the so-called ceramic electrolytes are inflammable. So from a safety perspective, they have a lot of advantages because they don't burn effectively. So safety is the main thing, and as more and more EVs become out on the roads, safety will become more of an issue, of course. So then the other advantage they have is that they pack really well. So these batteries are usually made in sort of flat packs, and so you can stack them, and you increase the energy density of the battery pack or the cell, simply because you don't have to worry so much about cooling. I guess not to get too technical about it, but they basically pack really well, and which we call bipolar packing. So that's the second advantage. And another advantage is that they have much better low temperature performance than a standard traditional lithium-ion battery, because the standard ones, the liquid gets very viscous when it gets cold. Whereas in a ceramic cell, it's just a solid that's containing these ions, and so there's nothing to get viscous. And they also have better high temperature performance because they don't have degradation problems, at least not as much as a traditional liquid electrolyte. So those are the three main factors.
And it's also my understanding that the hope is, because you mentioned, these aren't really on the mass market right now. There's a lot of work being done to bring it onto mass market in EVs, but they would also charge a lot quicker than the EVs that we have currently on market.
I think that there are many different flavors of solid-state batteries. And in principle, yes, they would charge faster. On the other hand, CATL has just announced a really, really fast charging traditional lithium-ion battery. That was just announced a few weeks ago, I guess. And so there's a lot of improvements being made in liquid electrolyte systems as well as solid state. So it's a little hard to say exactly, especially with respect to fast charging, how that's going to work.
Right. And can you share maybe some of the challenges in manufacturing solid state batteries? You said it's not on the mass market right now. And I know there's been a lot of work and just conversations around bringing solid state batteries to mass market. So what are some of the challenges that our manufacturers are facing with doing that?
Well, as I said, that's a little hard to answer because they're not in the mass market yet. But it comes down to, I guess the main problem comes down to, so because you're mixing two solids, especially at the positive side of the electrode. So at the negative side of the electrode, right now, a typical lithium-ion battery will use a graphitic carbon mixed with a little bit of silicon. And so that manufacturing is well established. And that can be used for the solid-state cell as well. So, but people really want to move towards either alloys or metallic lithium as the negative electrode. And so that brings a set of manufacturing challenges with it. And at the positive side, you have to mix two solids because the electrolyte has to be mixed with what we call the active cathode material. And so that manufacturing challenge is really just a question of how to get those solids evenly, nicely, homogeneously mixed, and how to really create thin films of those materials in order to assemble the cell. But in principle, it's most of those technologies are obviously established for a liquid electrolyte system. So it really comes down to materials manufacturing, the challenges associated with that.
Yeah. So with your knowledge of solid state batteries, and I'm sure you're well aware of all of the advances that are being done, when do you think everyday drivers can realistically see solid state batteries being introduced more commonly in EVs? And I see you smiling.
Yeah, because this, when you look at the announcements, it's going to be tomorrow.
Yeah.
And Toyota was claiming they'd have one on the road by 2027. I think it originally was 2025, and then they sort of get moved forward. I mean, realistically, I think 2030 would probably be the start of it. This is just my personal point of view, but it could happen sooner than that. Yeah. But the cautious people in industry quote 2030 to 2035, and The more optimistic will quote 2027, for example, which is only 2 years from now.
Thank you so much, Linda. This was such a great conversation. I know it was a quick conversation, but I think, like I mentioned, there have been a lot of conversations around solid state batteries. And to your point, there are always news articles coming out saying that they're coming soon. They're coming soon. But it seems like that's been said for quite a few years now. So thank you so much for just coming on and helping our audience understand a little bit more about this technology and what we can expect to see when it is introduced.
Okay, well, thank you very much for your questions. It's been delightful.
Thank you so much for joining us for another episode of the EV Life podcast. Make sure that you're subscribed so you never miss an episode. And if you'd like to join the conversation, you can always do so in the EV Life group on the AMA mobile app. We'll talk to you in the next episode.